Hello everyone. Today I'm going to do the project 2 presentations, which is based on the project 1, the Denmark Pavilion. The overall idea of this project 2 is to optimize the structures based on the several criteria I set. The first criteria set is to try to maximize the slope of the structures and make sure it is within the criteria, which is the maximum slope I set. And this part I used the Galpagos to generate it. As we can see that here, the index of the curve, when I change it to the different number, the overall structures may change to the different slope. So that I would like to calculate to make sure the maximum slope on the surface is also less than the maximum slope I predefined it, so that we can say that the overall structure slope is fulfill the overall structures fulfill the criteria I set. The step is to first calculate this. We can see that here in the screenshot. That will be more clear. First, I deconstruct the surface into many different points, and then using the Python script to calculate the steepest directions of each point. And then I calculate angles between the steepest directions and the z directions, which are the slope of each point. So that if after the calculations we selected the maximum slope of all of this slope, and then to make sure when changing the index of the curve, there may be several slope generated through this method, and we make sure this result is excluded, so that we can make sure the overall slope is less than the maximum slope. And the next criteria is to make sure the structures is not self-intersections. As we can see that here, as we change the width of the rectangle, they may have self-intersections. So in order to make sure the width is the whole structure is not self-intersect, so we have to calculate the maximum width of the rectangle. And I think the maximum width of the rectangle, which is the maximum width of the structures, would be the largest distance in the XY planes. We can see it here more clear. The line is representing the points in the Mobius strip, and if we make sure this part, which is the maximum distance between the points in the Mobius strip in the XY plane, is the maximum distance of the width of the structures, so that we can make sure the structure is not self-intersected in this place. This part is to calculate the maximum distance between the points of Mobius strip in XY plane, and this will be set as a criteria when using the second Galpagos. And the next step is to make sure the ratio of the height and the width of the structures. The original model of the Denmark Pavilion, the ratio would be the height would be the 0.45, which I set it as the original one. And the next part is to make sure the whole structure is within the bounding box. This bounding box is, in reality, it means that there's a certain areas and a certain high limitations of the existing size, so that we try to build a structures or the architectures to fit the bounding box. So the way that I did is to make sure the dimensions in x, y, and z directions of the bounding box of the structures is all within the range of the dimensions of the x, y, z directions of the existing bounding box. So that the final is to put all these criteria together into this Galapagos. As we can see here, the largest distance we just calculate to make sure that structures is not self-intersected, and make sure the ratio of the height and the width is 0.45, and also make sure the whole structures is within the bounding box, which achieve using these evaluations functions, because all the y, z, u is representing here. It is when they exist the range of the existing bounding box. This Python script makes sure these results will be excluded. And the genomes of the Galapagos would be the width of the rectangle and the scale. The scale makes sure the whole structures will be changed into different size, which may be generate the appropriate result to fit into the bounding box. And the thickness would be the maximum volume of the structures. And then after that, this is the final result of the two Galapagos procedures. That's all. Thank you very much.